We're going to talk about the differences between PPP and HDLC, when you can use them, how to configure them. Then we'll get further into point-to-point protocol with authentication methods of PAP, Password Authentication Protocol, and Challenge Handshake Authentication Protocol, as well as troubleshooting the Layer 2 encapsulation with PPP. I first want to talk about what Layer 2 encapsulation really is. Again, PPP and HDLC work at Layer 2, but it's Layer 2 of the OSI model, or the network access layer of the 4-layer model, the TCP/IP model or DoD model, people call it. Now, the Layer 2 is, again, the data link layer, and the data link layer is broken up into two sub-layers, LLC and Media Access Control, MAC sublayer. So Logical Link Control and MAC sublayer of the data link layer. Now, when you're packaging information, let's say you're sending something out from an FTP application at the application layer, it first goes to the transport layer and gets broken up into segments, smaller pieces called segments. Each segment gets information about how to put it back together, sequencing information, things like that. Then you send that segment down to the network layer or internet layer, layer 3 of the OSI model, and it gets the IP information thrown on there, assuming you're using IP. Then once that's in there, you send it to layer 2 of the OSI model. Now the very first part of that OSI model is the logical link control. And this is a big part of where HDLC and point-to-point protocol differ. You have your packet, which it's called at layer 3. That's called a packet there once it gets the layer 3 information on it. And what happens is the LLC part puts the type field in there. This type field tells the receiving computer what layer 3 protocol was used to package the information. So the receiving computer knows that all this data is packaged by the IP protocol. HDLC has a proprietary type field, meaning Cisco proprietary. So Cisco devices will work with HDLC. If you're not using a complete Cisco environment, you have point-to-point protocol, which has a standardized type field that has been revised by IEEE, and thus making it available to multi-vendor environments. So if you have not just Cisco, you might have Alcatel, other types of routers, you would need a protocol like point-to-point protocol to encapsulate the data, because this type field, again, which is used to tell the receiving computer the type of layer 3 protocol used, is standardized so multiple vendors can use it. Cisco has their own proprietary HDLC, and that type field is a proprietary type field. Then it goes on and puts the rest of the information on, as well as the trailer with an FCS flag in it, so it puts the rest of the layer 2 information on. But this type field right here is the big difference between HDLC and PPP, as well as some functions that are built into PPP that aren't available with HDLC. Let's go in and look at a quick comparison of HDLC and PPP. Alright, here's a slide that has the comparisons of HDLC and PPP. So we've got high-level data link control protocol, point-to-point protocol. HDLC is Cisco proprietary, meaning it only likes Cisco devices. PPP, multi-vendor. No error recovery, meaning it will not get a retransmission of damaged frames. There is error recovery with PPP. No authentication, meaning when it links up to a router at the other end, it doesn't have any way to verify that it's supposed to be able to link with that router. PPP has authentication, meaning it can verify that that router at the other end is his friend and he is able to send information back and forth. Looped link detection. A service provider will loop a link for testing purposes, meaning send bits back to the direction which the bits came. So if a router is sending bits out and the service provider has looped the link for whatever reason, he'll get his same information back. That's not good. He needs to send the information and have the other router receive it, not get that information back. So what would happen is he includes what's called this magic number, and we'll just use the number 1. If he sends bits out and he gets that same number back, then he's going to know that that link is looped, not the loop is linked. The link is looped, and he will stop transmitting on that link or consider that link down. HDLC will think that everything's happy, and he will just keep sending this stuff back, getting it back himself, and not even realizing that it's his own data. PPP also supports multi-link support, meaning aggregation of multiple links, allowing transmission of multiple links, information over multiple links acting as one link. So there's a lot of good benefits to PPP. PPP was developed later on, and they added a lot of benefits to PPP. Now, let's go in and look at PPP a little bit more closely before we go in and configure HDLC and point-to-point protocol. To get a little bit further into PPP, point-to-point protocol, I brought up another slide. There are two main components of PPP. One part of it, link control protocol, is the part that is used with any protocol, and that's the part that authenticates the line, the loop link detection, the multi-link support. So if we have two routers connecting together, link control protocol is going to set up the link between the two routers, monitor the link, and make sure it's appropriate to carry the traffic across. Then you have specific control protocols, and it's a specific protocol to certain protocols. Meaning, if I'm sending an IP packet across the link, I would be using the IPCP protocol, IP control protocol. If you're sending a CDP packet across the link, you would be using the CDP-CP protocol or IPX-CP protocol. They've got them for AppleTalk. Every layer 3 protocol out there, they're going to have a certain control protocol that goes along with it. And what that does, it allows for the point-to-point protocol specific features that support IP, CDP, IPX to work with that particular layer 3 protocol. An example of this would be IP address assignment with an internet dial-up connection. So the two protocols, link control protocol and then the individual control protocols, work together to set up the link and allow the traffic to be carried across it. Link control protocol, like I said, does the authentication. Now, there are two main authentication types you need to know for the CCNA. One is PAP, two is CHAP, Password Authentication Protocol. And with Password Authentication Protocol, what happens is when the routers, before they transfer any data, if you're having authentication, this is optional, by the way. If you're going to send information across and you're using authentication, with PAP, it just sends the host name and password across in clear text, meaning if anyone was listening on the line, they're going to be able to get that information. Challenge Handshake Authentication Protocol sends a challenge first before sending the username and password across. So the host name of the router, this might be ROA for router A. This might be ROB, ROB for router B. And there is a password that must match on each router that's been pre-configured. Let's say the password is 123 on both routers. With Challenge Handshake Authentication Protocol, what happens is the initial challenge sends a number across. Sends a number like multiply your password or whatever by this number right here. It's a little algorithm that gets worked on the number here. And Rob sends the host name and whatever answer he got by using that initial information from the challenge. The actual 123 password never gets sent across the link. This guy does his own calculation on the password and verifies that the information he received from ROB router matches. If it matches, they both match, they're going to be able to communicate. So what's cool about that, the password never actually crosses the link. Let's take a look at what we need to configure to get point-to-point protocol to work. HDLC that we talked about a little bit earlier, that's the default. It's already configured. We don't need to do anything on our serial interface. HDLC is already done. If we want the extra features, the authentication, multi-vendor support, we're going to have to go in and configure point-to-point protocol. Let's take a look at what it takes to configure this point-to-point protocol and make sure it works. Here's the diagram of a couple of routers. We've got Palestra 1 here and Palestra 2. There is a serial 0 connection between the two and a WAN link, simulated WAN link. I've actually gone into the simulator and configured IP addresses. One 1.2, 1.1 and 1.2 with just a regular class C subnet mask. So they can ping each other in the simulator. I have this configured. The names are configured Palestra 1, Palestra 2. There is a username command that we need to set up to be able to configure PPP between the routers with the optional authentication. What we have to do on Palestra 1, so on Palestra 1 we'd be typing this in, username Palestra 2. We have to type in the username and the host name of the next top router that we're going to be communicating with. This is basically like creating a user account for the next top router for authentication purposes. Then you type password and then a password. Very important, these two passwords on each side here. So you go password Cisco, password Cisco. They must match. If the passwords do not match, it's not going to function. So on Palestra 2, you type username Palestra 1, password, and then the password. On Palestra 1, you type username Palestra 2, password, then the password. And think about why these have to match. Remember, with authentication of CHAP, Challenge Handshake Authentication Protocol, they run a little algorithm on this password and get a particular number and send that across. They don't even actually send the passwords across. So if the passwords don't match, they're not going to be able to authenticate. After I've created the user account and verified that the host name is correct, then you can go to the interface, type encapsulation PPP, PPP authentication CHAP, and then you can set it up on both sides. Make sure it's set up on both sides. If the authentication does not match, like on one side you're using PAP instead of CHAP, not going to work. So the authentication must match, encapsulation, as well as the passwords, and then the user account, the username, has to match the host name of the next hop router. If any of those things are off, layer 2 will not come up. So let's go to the actual simulator and configure this and see what happens. In my simulator, I'm at router Palestra 1. I'm going to enter the router, and I'm going to go in and configure PPP. So I get into global mode and I type username Palestra 2, password Cisco. So Palestra 2 is the next top router that I'm connecting to, and then again the passwords are going to have to match on Palestra 2. So Palestra 2, I'm going to type username Palestra 1, password Cisco. They got to match and they are case sensitive. The username again just creates a user account basically for Palestra 2 for the authentication purposes. Once I've done that, I go to interface serial 0 and I type encapsulation PPP and then specify the authentication, PPP authentication CHAP. I'm going to shut this interface down, so after I configure Palestra 2, I can come back over here, turn it on, and debug the authentication. Debug allows me to view the authentication as it takes place. Debug PPP authentication. This is a very important command, and you would particularly use this if for some reason layer 2 was not coming up when you check your interface status of your serial 0 interface. You'd want to check the authentication and watch it and see why the authentication wasn't functioning. Let me go over to Palestra 2 and configure that. So I'm in privilege mode, get into globe mode, username, Palestra1, password, Cisco. Again, case sensitive, so passwords must match, they match. This is the host name of the Nextop router, not case sensitive. Go to interface serial 0, encapsulation PPP, PPP authentication chat. No shutdown, make sure it's turned on. Palestra 2 is configured. I'm going to save it real quick. Go over to Palestra 1 again, and I'm going to go in and turn on the interface. So I'm going to go to interface serial 0 and type no shutdown. Now remember, I turned debugging on right here. I typed in debug PPP authentication. So when I turn this interface on, I should see the authentication take place. And there it is. No debug. I'm going to turn it off right now. And typically I would just type in no debug all, but the simulator is making me type no debug PPP authentication, which is a perfectly valid way of turning PPP authentication debugging off. It's just simply easier to turn all debugging off because you don't typically have a lot of debugging running. So by typing no debug all, it'll go off. Also, I noticed that on the simulator, it keeps authenticating over and over, and it's saying success. What would happen on your actual router, in your actual environment, it would stop right here. Once it hits success, you're done. It's not going to keep authenticating over and over and over again. So you see success, success, challenge from both sides. You get the successes for both challenges. Everything's good. You're up. You won't keep seeing this authentication run over and over again. That's just one of the small problems with the simulator. It just keeps running. So we turn that off. If I type in show interface serial 0, I can see that. Let me try that again. Interface serial 0. There it is right there. Serial 0 is up. This is layer 1, meaning layer 1 is up. Line protocol is up, meaning layer 2 is good. If it said is up, line protocol is down, then we know we've got a problem. Either the clock rate's not set on a back-to-back environment, or again, something wrong with the PPP authentication. If this was saying is down, one of the first things I would do is I would turn debugging on. I would turn debugging on just by typing in debug PPP authentication. And that would allow me to see the authentication as it's taking place. No debug PPP authentication. Again, if there was a problem, it would keep scrolling and it would keep trying to authenticate. Here it's saying success, even though there's no problem, and it keeps going. Again, that wouldn't normally do that. I would do a show run. Now, when you're having problems with this authentication, you've got to verify that the host name is right, because this is sending the host name over as part of the authentication. If the host name's not right, not going to authenticate. This is one of the things the simulator does, redundant commands in here. Only one would show up in there. If they were both the same, it'd overwrite. So I would check username Palestra 2, password Cisco, make sure the password is right. Now, normally this router right here, this command, service password encryption, that command normally will say no service password encryption by default. Here, service password encryption is turned on, meaning every password on the router would be encrypted. So instead of seeing Cisco here, we should see an encrypted version of a password, something like this, meaning I couldn't tell what the password was with service password encryption turned on. So as a troubleshooting method, I would go in, I would just retype out this line. I would type username Palestra 2, password Cisco, just to make sure it was right. I would do that on both sides if I'm having trouble authenticating. I would also go over to Palestra 2 and verify the host name over here. Check every character, make sure there's no underscores, or maybe the E and A could be swapped, something like that. Those host names aren't exactly right. Again, authentication won't take place. I would also check out the username Palestra 1, password Cisco. I would just retype it out if I couldn't see the password and verify that the password. So I'd always go in and basically reset this account. I would also go and check the show run and check the interface. Verify the encapsulation on the interface. PPP authentication chat. I would verify all of those things. IPs don't come into play here. They will come into play if the interface is up and up and I can't ping. But if the interface is up and down, I need to simply focus on layer 2 encapsulation and problems with the authentication. Making sure that the authentication is CHAP, making sure encapsulation is PPP and not HDLC. If I were to get rid of that and maybe set HDLC, whoops, encapsulation HDLC, not CL. If I do a show run, I don't see anything there. This line should actually disappear, by the way, on the simulator. But I wouldn't see anything there. So what I'd have to do to verify the encapsulation is do show interface serial 0, and I can see the encapsulation there. Encapsulation HDLC. The other side is encapsulation PPP, so that's not going to work. If I do a show interface, notice here it says line protocol is down, meaning again layer 2 problem. I just did the show interface. So again, line protocol is down, here is up. Layer 1's good. Line protocol down, layer 2 bad. And the reason it's bad is because this end I'm using HDLC, the other end I'm using PPP. So let me bring back to the slide and verify everything you should check when you're troubleshooting line protocol being down. Here's my slide on everything that needs to be configured. And when you're troubleshooting line protocol being down and you're suspecting something with PPP on the authentication, first thing, verify the host name. I do a show run, check the host names out. Because remember, this host name needs to match the name in this statement. It's not case sensitive, but you can make it case, put the case there if you want, the uppercase when necessary. But that must match. If they don't, something's different, not going to function. These passwords have to match. If the passwords are encrypted, simply retype out username Palestra1 password Cisco and it'll overwrite the other one, resetting the password. These are case sensitive, and again, they've got to match, so check those out. Encapsulation PPP needs to be done on both interfaces, and the authentication has to match. If one side's CHAP and the other side is PAP, it won't work. They both have to be CHAP. I have seen people overlook the host names not being typed right, or the username specifying the username not typed right, passwords not matching for something, improper authentications, improper layer 2 encapsulations. If this was HDLC, again, not going to work. So you just need to go in and verify every one of these carefully. If you have to, retype and make sure you get the right ones. Again, for a little help with this to find out why it's not authenticating, if that's the problem, debug PPP authentication will show you the authentication as it takes place, and if there's a problem, it'll tell you what the problem is. Like you might get an MD desk compared failure, and what that means is the passwords are not matching. So debug PPP authentication, very important, and use that to help figure out what the problem is with the authentication, as well as the show interface, because your first goal is make sure the interfaces on both sides are up and up. The first up is layer 1, second up, layer 2. Then worry about pinging. We have talked about PPP and HDLC layer 2 encapsulation, PPP and HDLC comparison there, configuration of PPP, more specifically HDLC is by default, and again to configure that all we type is encapsulation HDLC and it's done, or turn off PPP on the Cisco router and HDLC is there by default. So not a lot going on there with configuration. How to set up authentication. The differences between CHAP and PAP, Password Authentication Protocol, again, not very secure. CHAP, much more secure. as well as troubleshooting that Layer 2 encapsulation. I hope you have enjoyed this Palestra training video on PPP and HDLC Layer 2 encapsulation.